Hello good people, I'm going to talk about addition and subtraction of like terms and their factorization. It is very important to keep in mind that it is only the like terms that can be added or subtracted. Why is that, and what does it mean in the first place? Let me bring in an example. Here we have 3 rooms with different number of patients, and we also have a student nurse. As it happens, this student nurse will spend 5 minutes with each patient while doing their rounds. How long will it take for the student nurse to finish their rounds? One way to go about this is to calculate how long the student nurse will spend in each room and then add those times together. In the first room, room A, there are 4 patients, and we are going to multiply that by 5 minutes. Then we have the second room, room B, with 2 patients, and that will be multiplied by 5 minutes too. Finally, we have the third room with 3 patients, and that will be multiplied by 5 minutes. What are the products of these multiplications? 4 by 5 is 20, 2 by 5 is 10, and 3 by 5 is 15. And now if I add these numbers together, I will end up with 45 minutes. This is a perfectly reasonable solution, but let's do it another way. What is a common factor for all these rooms? Well, the common factor happens to be 5, because each time we are multiplying by 5. And so I'm going to isolate the common factor 5, and then I'm going to open a bracket and add all of the values. 4 plus 2 plus 3, and close the bracket. What will that give me? Well, I will have 5 multiplied by the sum of these 3 numbers, which is 9. And so I will have 5 multiplied by 9, that is 45. In essence, I have added all of the patients together and then multiply that by 5. How does this thing work with algebra? How does it work when we introduce letters? Let's suppose there is another student nurse. And it turns out that this other student nurse spends h minutes with each patient. We do not know what h is, but we can still create a mathematical expression. In room A, I have 4 patients, and I will multiply that by h. In room B, I have 2 patients, and I will multiply that by h as well. In room C, I have 3 patients, and that will be multiplied by h. The common factor is h, so I can take it outside of a bracket, and then inside the bracket I could put in the coefficients. 4 plus 2 plus 3, same as before. And that will give me h multiplied by 9, which we can express as 9h. In other words, I have added all of the h terms together. 4h plus 2h plus 3h gave me 9h. And even though I do not know what the value of h is, I can still add the h terms, because whatever it is, it will be the same for all of the terms. Let me do a few more examples. You are welcome to pause the video and solve these questions first. In the first instance, we have 4a plus 3t plus 12a plus 2t. What are the like terms? 4a and 12a are like terms, 3t and 2t are like terms. I can say 4a plus 12a will give me 16a, and 3t plus 2t will give me positive 5t. The next expression is 3c minus 8f plus 6c plus 5f. 3c and positive 6c are like terms. I can add them. That will give me 9c. Negative 8f and positive 5f are like terms. Negative 8f plus 5f will leave me with negative 3f. Please note that this is as far as we can take this. I cannot subtract 3f from 9c because they are not like terms. The third expression says 7g minus 10n plus 10g plus 12n. 7g and 10g are like terms. I can add them. That will give me 17g. Negative 10n plus 12n will give me positive 2n. The last mathematical expression is 8x squared plus 6x minus 3x squared plus 9x. What are the like terms here? Recall, for something to be a like term, the letter and the power need to be the same. And so 8x squared and negative 3x squared are like terms. 8x squared minus 3x squared is 5x squared. Positive 6x and positive 9x will give me 15x. In each of these cases, we can also look for common factors. In the first case, we have 16a and 5t. We are looking for a common factor for 16 and 5. Unfortunately, there are no common factors. Recall that a common factor would be a number that both of these values are divisible by. So in this case, this is as far as we can go. When it comes to 9c minus 3f, all right, now there is a common factor. Both 9 and 3 are divisible by 3. So I could take 3 outside of the bracket, and now I have to ask myself, what do I have to multiply 3 by to get to 9c? Well, the answer is 3c, because 3 multiplied by 3c will give me 9c. What do I need to multiply 3 by to get negative 3f? Well, I need to multiply it by negative f, because negative f multiplied by 3 will give me negative 3f. When it comes to the third expression, we have no common factors. 17 and 2 do not have a common factor. What about the last expression? Well, both 5 and 15 are divisible by 5, so I could take 5 outside of the bracket. If I want to get to 5x squared, I need to multiply this 5 by x squared. If I want to get to 15x, I need to multiply this 5 by 3x. This is a perfectly fine factorization, but we could get a bit fancier. Yes, in both of these cases, 5 is a common factor, but so is x, which means I could actually say that 5x is a common factor. If I want to get to 5x squared, I need to multiply 5x by x. And if I want to get to 15x, I need to multiply 5x by 3. In summary, it is only the like terms that can be added or subtracted. And if we want to get a bit fancy, we can also look for common factors. That is all for now, and I will see you on the flip side.